Good morning. Doing a video here to go over the Unit 1 test review as promised. And so let's go ahead and begin. I'm not going to go through every problem. I'm just going to sort of go through the problems that are sort of alike. So I'm going to start here with number 2. So number 2, if negative 9 is an element in the domain. Hang on. Okay, we're back. So negative 9 is an element in the domain. Okay, an element in the domain. Domain is x value, so negative 9 is an x value. Okay. So if negative 9 is an x value, we want to find the corresponding element in the range. So all we're going to do is plug in negative 9 for x right there. So 5 times negative 9 plus 40 all divided by 2 would be a good idea also to put parentheses around that whole top thing right there just to make sure we're good. Okay, so 5 times negative 9 is negative 45 plus 40, negative 5 over 2, which is equal to negative 2.5. Okay, so that's all it's going to ask. That's all you have to do when they give you this question. Okay, they're going to give you a number. You're going to plug that number in for the x, and you are going to do your order of operations, PEMDAS, to get the corresponding value of y. Okay, let's bump down to number 4, finding the value of x. Okay, find the value of x. So again, first thing we need to do is simplify each side, combine like terms on each side. And if once that's done, then we get the x by itself. Okay, so starting over here, we have 3x minus 7 parentheses x minus 3. So first thing we need to do is we're going to distribute the negative 7 through x minus 3. So we have 3x minus 7x plus 21. Okay, because negative 7 times x, negative 7x, negative 7 times negative 3 is positive 21, equals x plus 1. Okay, so we got to distribute, get rid of the parentheses. Next, what we're going to do is we'll combine like terms. We cannot combine like terms with the x plus 1 over here. They're already combined. We can combine like terms over here on the left-hand side. So 3x minus 7x is negative 4x, plus 21 is sort of by itself, and that equals x plus 1. All right, we need to move the x's all over to one side. So I'm just going to move the 4x over. So we'll add 4x, okay? Bang, out. And so we have 21 equals x plus 4x is 5x plus 1. Now we got to move the numbers over to the other side. So we minus 1, 5x equals 20. We divide by 5 and get x equals 4. Okay, just like the discussion question we had, I don't know if it was last week or 2 weeks ago, but one of those. All right, next one, number 5. This is a key one right here. We could do this one 2 different ways. The easiest way is we can graph all 4 of these functions in Desmos and see which one works. So we need to see a domain of x being greater than or equal to 7. Okay, x being greater than or equal to 7. And notice we have square root functions right there, so that might be a little bit of a clue. So if we were to do this in Desmos, and you'll have access to the Desmos thing as well. So if we have y equals, I have to type it in. So y equals, let me get this out of the way. 5 root x plus 7 minus 4. 5 square roots x plus 7, right arrow minus 4. Okay, we see that the domain starts at negative 7. The domain starts at negative 7, so we know that the x is greater than or equal to negative 7. So that one's out, okay, because we need to be x is greater than or equal to 7. 5 parentheses x minus 4 rooted minus 7. So let's try this. Y equals 5 root x minus 4. Right key minus 7. Oh, 76. There we go. All right, there's that blue one. All right, and looking at where the domain starts on this one, the x values start at 4, so we know x is greater than or equal to 4 for that domain right there. Well, that's out. Okay, we need x is greater than or equal to 7. Let's try the next one. -2 root x minus 7 plus 16. So we have y equals -2. This thing keeps getting in my way. Root x minus 7 and then plus 16. So -2 x minus 7 plus 16. So this is purple one right here. All right, and this purple one right here, the domain starts at 7 and it goes off this way. So this domain is x is greater than or equal to 7. So we have a winner. Okay, x is greater than or equal to 7. Okay, so we could plot these in Desmos and get the things right there. We could also go back to our transformation rules. Okay, we can go back to our transformation rules, and here's what I mean. We see all these functions are roots. They're square root functions. The parent square root function looks like this, right? With a domain of x being greater than or equal to 0. The domain of the parent square root function is x is greater than or equal to 0. Okay? If we're trying to find a domain of x being greater than or equal to 7, what we really need to do is we're going to take the parent function and we're moving it to the right by 7. Okay? Whenever we're moving a function to the right by 7, we have a horizontal translation to the right by 7. What we do in the parentheses is instead of x, we do x minus 7. Okay? So it becomes f of x to f of x minus 7. Okay, so in the parentheses with the x, which in this case is within the roots, we need a root that minuses 7 inside that thing. Okay, minusing 7 inside that thing moves the graph to the right. And I know the graph was also transformed, so it kind of looked like this, right? But again, all we're kind of worried about here is a horizontal transformation. Okay, the rest of the transformations really kind of don't matter. And so here at this thing, x is greater than or equal to 7. Okay, so a couple ways. We can guess and check in Desmos, plug them in, or we can use our transformation rules. Either one works. Either way works. A logarithmic function has an x-intercept of 8 and a vertical asymptote at x equals 3. So looking at our parent logarithmic function kind of looks something like this. Right, where we have an x-intercept at 1. So 1, 0 is our x-intercept. And then we have an asymptote right there at the y-axis. Okay, that's a parent logarithmic function. That's our y equals log base 2 of x. All right, so this other one is just a transformed logarithmic function. So we have an x-intercept at 8. So our x-intercept is there at 8, okay, instead of 1. And we have a vertical asymptote at 3. Okay, so we have a vertical asymptote there at 3. So the sketch of this function is going to go through 8. It'll dip down like this and never cross the 3. Arrow down here, arrow up there. Okay? That should be that. Sketch the following function square root. You could type these in the calculator and do these yourself on Desmos if you don't already have sketches of these. So the square root, we have our f of x or y equals root x. Cube root, what you'll do in Desmos here is y 3 of x. Okay, you could also do, it's the inverse of y equals x cubed. So you could also do x equals y cubed if you want to just type it in a calculator like that. Okay. Logarithmic function, log base 2 of x equals y. And I don't think, let's see, under functions here. Yeah, so we'll go to calculus. We'll hit the log button there, base 2 of x equals y. Just make sure you do the log with a little number underneath there. So you get your log function. And exponential function, which is, of course, y equals 2 to the x power. So on this one, you just need to sketch all 4 of these and know what they look like. Sketch all 4 of these and know what they look like. One moment. All right, sorry, we keep getting interrupted here. All right, so let's look at 10 and 11 both here. So f of x equals root x and g of x equals this. So we want to describe the transformation. So let's kind of work left to right, okay? Here, starting with the negative on the outside, the negative on the outside is going to give us a vertical reflection. So vertical reflection. Okay. We have 4. Okay. So we're also going to have a vertical stretch. Okay. And then we have plus p inside here. So inside the root, okay, it's a horizontal shift. And we're plusing p, all right, and we're going opposite. So inside the horizontal shift, when we add, we go opposite. So we're going to the left by however much p is. Okay, so we have a vertical reflection with the negative, vertical stretch with the 4, and plus p tells us that we are going to the left. Okay, if we're looking at the next one, we have 2 negative x minus p. So the 2 on the outside gives us a vertical stretch again. So we have vertical stretch. Sorry about my handwriting. Negative x, so now the negative is with the x, so that's going to be a horizontal reflection. Horizontal reflection. And then minusing p, so we minus p inside the root, tells us that we're going to go to the right by p. Okay. Number 13. If f of x equals -4 parentheses x plus 7 minus 2, graph the inverse and find the x and y intercepts. So this should be a nice simple one right here. So, we go into Desmos right here. So if we want to graph the original, we can. If we want to just go straight to the inverse, we can. So there's our original. Y equals -4 parentheses x minus 7 minus 2. And of course, with the inverse, we just got to go the opposite. So x equals -4 parentheses y plus 7 minus 2. All right. And so if we're looking for our x and y intercepts here, we have an x intercept of -30. And a y-intercept of -7.5. All right. So the x-intercept will be at -30, 0, and the y-intercept is going to be at 0, -7.5. All right. This one's going to be a multiple choice thing on the thing, and you just need to make sure that you know which picture goes with the inverse. Okay. All right. So number 14, if f of x is 2x minus 4 and g of x is x squared plus 5, so find f of g of x. So we're going to take our f function, 2x minus 4. Okay. And so of g, so now g goes in for this x. So we're going to have 2 x squared plus 5, because that goes in there, minus 4. And if we wanted to distribute, we'd have 2x squared plus 10 minus 4, which would be 2x squared plus 6. You shouldn't have to reduce and simplify for the test, but it's always good practice to sort of do that. If we're going g of f of x, so now we're going to take our x squared plus 5. And for the x, we're going to plug in 2x minus 4. So what we're going to have is we're going to have 2x minus 4 squared plus 5. 2x minus 4 squared plus 5. If you're doing g of f of x. Okay, this one, kind of a little wordy. Maybe worded a little bit weird, but so first of all, what we want to do is we want to find the x and y intercepts, and this is going to be a picture matching one as well when we take our test. So given the function here, we want to find the x and y intercepts for the inverse function. So if we find the x-intercept for this one, so the x-intercept for the original one is going to be 1, 0. And the y-intercept on this one, it's not quite -2, but it's really close. We'll call it, maybe -1.8. Okay, and that's for f of x. So remember, when we do the inverse of f of -1, okay, the x-intercept becomes y-intercept. So the x-intercept for the inverse is going to be -1.8, 0, because the x's and y's flip. The y-intercept would be 0, 1. Okay, find two other points that will appear on this. So let's just find two clean points here. So here we have the 0.25 on the original. And we also have right here maybe -1, -2. And you can find any point you want. I'm just trying to show you all a nice clean picture here and find some easy points. So 2.5, -1, -2. So on the inverse, f of -1 of x, we'll have the 0.52 and the point -2, -1, because again, we have to flip the x and the y's. Okay? Again, this is going to be a picture matching one right here. I just wanted us to sort of understand the process of how to do this one rather than actually match a picture here on the review. Okay? So look at the intercepts. Look how the intercepts flip. Okay? See if we can find some other points on the original and match them up with points that would be on the inverse. So that's our video for our Unit 1 test review. That covers pretty much everything. Make sure you make your 2 note cards, handwritten, front and back. You got 2 of them. And bring your Chromebook charged fully tomorrow to take your test. And you guys have a good day. Thank you.